Instrument types form a foundation and a basis for collecting failure rate data for different types of equipment. But at the next level, there are sensors, logic solvers, and final elements that are components to a safety instrument and system. They are the unique individual instances of the different types of equipment that are available. If you want to create a new component or view components, you can either click on the Add New button and then select what type of component you want, sensor, logic solver, or final element. And the same with View will give you the list of sensors, logics, solvers, and final elements that are contained in your study. So let me go and bring up the sensor list. So these are the sensors that have been defined for this particular study. You'll see that they are unique instances, each having their own tag name, but they may be of similar or the same instrument types. So if I want to create a new instance of a sensor, I can again either click the Add button and add a sensor, or since I'm already in the sensor list, I can just click Add New Sensor. When I do so, it will bring up the sensor details form or the component details form, because this form is going to be largely the same regardless of what instrument type, what component type you're trying to define. So the first thing that you need to do when you click on the component details form is you need to select the type of instrument. So if I were creating a new pressure transmitter, let's call it pressure transmitter 002, and this would be in a service where I'm trying to where it will trip upon high pressure. So I would put the tag in, but the first thing I want to do is select the type. So when you click on the drop-down box under type, it's going to show you the list of instrument types that are available in this project that you have defined for this project. If what you want is not available on this list, you can create a new sensor type by clicking on the New button, and it will bring up the familiar sensor type dialog box. But let me go ahead and select a pressure transmitter generic in a high trip application. So that sets the type for this specific instance of transmitter. Then you put in the service description for the transmitter. Let's just say low pressure separator V102. And then you can define some of the attributes about how that device is installed and maintained and tested. So one of the most important attributes is going to be the test interval. So let's say it's tested on an annual basis. That would be 12 months. You can select a voting arrangement, and the voting arrangement in Vertigo, you have a large number of standard voting arrangement types available. 1 out of 1 being simplex, 1 out of 2, meaning any one device out of a total of 2, if it votes to trip, the trip will happen. 2 out of 2 means 2 devices out of 2 have to vote to trip in order for the trip to happen. 2 out of 3 voting, and then some other somewhat less common but still used occasionally, 1 out of 3, 3 out of 3, 1 out of 4, and 2 out of 4 voting. There's another item here called complex, and complex is not something that you would select. So let me just go ahead and say 1 out of 1 voting here. Now, it shows 1 out of 1 voting because the instrument type contains failure rate data, so Vertigo intends to calculate the failure rate or the failure characteristics, the PFD and the spurious trip rate. But if I were to select a black box model, it will automatically change the voting type to be complex, meaning that the simple voting arrangements that are displayed aren't suitable for performing the calculation, and instead it's going to take the PFD and the spurious trip rate directly from the black box model definition. So let me go ahead and put it back to a normal pressure transmitter and select 1 out of 1 voting. And then finally, down at the bottom, we have the device selection basis. So for every type of device that is used in a safety instrumented system, you need to have a basis for justifying that it's suitable to use it in a safety application. And that can either be prior use experience, or the device can be designed and manufactured in accordance with IEC 61508. Our shorthand for that is saying that it's IEC 61508 compliant. So that's an option. Prior use is an option. Now, or you can also say proven in use, which is more of a 61508 term. Whether you use prior use or proven in use, the mathematics are essentially the same. Now, when you select prior use experience, you have a checkbox here that says reduce fault tolerance. In accordance with the IEC 61511 standard 2003 version, if you have prior use experience with a device, then the hardware fault tolerance numbers that you can select out of the tables can be reduced by 1. Well, although you can reduce the hardware fault tolerance by 1, you may not need to, you may not want to when you're performing your risk analysis. So the Vertigo software will only take that -1 reduction in the required hardware fault tolerance if you check the reduce fault tolerance button, which is only going to be visible when you select prior use, because you see if you select IEC 61508 compliance, that option isn't available to you. Now, we have defined the type of sensor, but sensors are more complex than just the device itself. There are other ways, other areas where a failure can occur in a sensor subsystem that are not specifically related to the sensor itself. And those items are process connections. So a process connection can be something like impulse piping or a remote sealing system. So we give you the ability to put in a process connection, such as tubing in clean service. And if you don't see the process connection that you would like, you can once again create one by clicking the new and picking something out of the library and bringing it into your study. You also have the ability to define 2 sensor interfaces. So an interface is going to be something that is in between the sensor itself and the logic solver. Now, typically you will consider things like intrinsic safety barriers to be sensor interfaces. Also, depending on how you perform your modeling of your logic solver, you might also want to put input cards or input processors that are associated with an input in as a sensor interface when you're doing your calculations. When we start talking about logic solvers, we'll go into a little bit more detail on what information you need to put in. Once you define all of that information, you're going to get a calculation shown to you that shows you all of the component failure rates broken down based on the equipment you selected and the choices you made about how the equipment is installed. So in this case, you see that there are failure rates associated with the process connection itself, the sensor type, and they are all summed up for the overall system failure rates, which will then be used for the PFD and spurious trip rate calculations.